Hi everyone. Let us talk about implementing survival analysis for predictive modeling. Now, what is survival analysis? Survival analysis is a set of statistical approaches used to predict the time or until an event of interest occurs, such as failure of a machine, relapse of a disease, or a customer churn. This is widely used in fields like healthcare, engineering, finance, and social sciences. Implementing the survival analysis for predictive modeling uh, involves several steps from understanding the key concepts and how it can be applied in predictive modeling to deploying the final model. So, different things that we need to understand before we get into survival analysis is survival function. So we study an event and how it decays over time and how the probability that it occurs or the time taken for it to occur, right, is larger or smaller than the specified time. So if you see, this is called survival function. Survival function is the probability that the time to the event is longer than a specified time. Similarly, hazard function, it is denoted by S of t. Hazard function is the instantaneous rate at which the events occur, given there is no prior event. Censoring occurs when the event of interest has not been observed for some subjects during the study period. Like it could be left censor, right censoring, which means the event has happened after the study is over. Left censoring, where the event has occurred before the study has started, and interval censoring. It has occurred at some period in between our observation time, but has not been recorded. So right censoring is most common where we know that the event hasn't occurred until a certain time. Now, time to event data. Data that includes the time until the event occurs and an indicator of whether the event was observed or censored. Now, your data set also has to be compliant with the expectation of your survival analysis algorithms. Now, to perform survival analysis, your data set should have a duration column, the time until the event or censoring, whatever it is, event indicator, possibly a binary variable indicating whether the event has occurred or was censored. Next, covariates can be, covariates is just like your features, independent variables that may influence the time to event. Now, looking at the steps to implement survival analysis, the first step includes importing and installing installing and importing all the required Python libraries like lifelines, scikit survival, as well as stats model. And the data preparation, which involves cleaning, encoding, and scaling, on a concept level is very similar, but we have to handle missing data as well as convert categorical features to numerical formats, feature scaling, as well as splitting the data into feature and target, testing and training as well. Exploratory data analysis involves survival curves, hazard plots, as well as feature analysis. And as a feature analysis involves assessing the relationship between the features and survival. Hazard plots involve how hazard changes over the time. Survival curves involve plotting Kaplan-Meier curves to visualize survival probabilities. Now, choosing the right model. There are a lot of them available. Kaplan-Meier estimator is a non-parametric method, while Cox proportional hazards model is semi-parametric, while accelerated time failure time models are parametric models that assume a specific distribution of survival times. Random survival forests are very similar to your random forest algorithms. They are ensemble methods suitable for complex relationships. Deep learning models handle larger and complex data sets. Now, after that, we fit the model and evaluate the model. Now, let us see a similar Jupyter implementation of the same on a small synthetic data set that is being generated. So I start with installing lifelines. Pandas and NumPy are already there with me. So after I install, I have to import libraries. So I import pandas, NumPy, Matplotlib for enabling plots, as well as I import Kaplan Mayfitter as well as Cox PH. First, my point is to generate a synthetic data set. I am seeing the age of the patient as well as the treatment given to him among A and B, two treatments. I am giving him one treatment. Now, the duration of the treatment being given and the event is survival. One is survival. Now, as I see, event is whether the treatment has been given or not, censored during our observation period, right? So I create a data and then one hot encode the categorical variable involved here. Treatment is the only categorical variable and I encode it. So using pandas get dummies function, I encode it. And I drop the original column by choosing the argument drop first. Now I split the data into features and target. So duration and event are going to be my target variable, while age and treatment are going to be my features. Now, if I plot the survival curve for the entire data of duration and data of event, if I plot it, this is how my plot is going to be. Right? The survival probability as the age increases, as the duration increases, the survival probability comes down. Similarly, the probability of that event happening. Now, because the data is already encoded and it is very small data, synthetically generated, there is nothing to clean in that. So I directly proceed to implementing a Cox proportional hazards model where I import the model and then fit the data. And if I print the summary of model, this is how it's going to come here. These are the expressions, these are the covariate features, age and treatment, and the coefficients of them. Right? And the standard error, all of that, 95% confidence interval upper limit as well as lower limit. Right? Similarly, if I plot this for first 5 individuals, the same survival rate, I predict for the first 5 individuals and then I plot it. If I plotted the graph, I just beautified the graph with choosing options of Matplotlib. If I plot the graph, this is how I'm going to get the survival rates of the first 5 patients. Please remember that this is synthetic data and you might see each of them tracking very similarly the other path, but it is not going to be like this in real case, right? So as the duration progresses, the survival probability keeps coming down. So like this, a lot of things, by choosing much more wide data, by choosing a lot of other steps and a lot of parameters, we can do much more with this survival analysis. Now, let us have a look at common survival analysis models and how they compare against each other. So, usually, non-parametric models assume no distribution, and then parametric models assume that the data follows a certain level of distribution. Now, Kaplan-Meier estimator is usually used to estimate survival functions from lifetime data. Now, the advantage is that it is very simple and non-parametric. Now, the disadvantage is that it is limited to univariate analysis because it doesn't let many features be in the data. It cannot handle covariates in the first place. So it's more like a time series analysis where you have only one feature with time. Now, Cox proportional hazards method is usually used to analyze the effect of several variables on survival. It is semi-parametric. The advantage is that it is interpretable. Its coefficients are interpretable. The Disadvantage of this model is that it assumes proportional hazards, which may not hold true in reality. When it comes to accelerated failure time models, AFT models, they directly model the survival time. The advantage is that they do not assume proportional hazards. At the same time, the downside is that it requires you to specify a distribution for survival times. They are strictly parametric. Random survival forests or ensemble techniques, and they handle high complex interactions and nonlinear relationships. So, in that way, the advantage is that they handle high dimensional data and they are very robust to overfitting. The downside of this is that the model is less interpretable. Similarly, deep learning models also capture complex pattern in large data sets. They are highly flexible and predictive. But the downside is that it requires large data sets to train on. The results of deep learning models are usually less interpretable. However, they serve as an efficient tool when your data is really complex. Let us look at the application of survival analysis. We see survival analysis being applied in healthcare, where you analyze the patient survival of a treatment or estimating the impact of risk factors on survival, all of it. Similarly, in business, you kind of see this survival analysis being done for customer churn analysis or estimating the warranty or product failure rates. Similarly, in engineering, you do reliability testing. In social sciences, uh, you can analyze the time until an individual achieves a milestone, like employment after graduation, all of it. In clinical trials, also, we do this, comparing the efficacy of the treatments over time, all of it. Survival analysis is that way a powerful statistical tool to model time to event data. By handling censored data and focusing on survival probabilities and hazards, it provides insights on how long events take to occur and what factors influence them. This is the end of a brief note on implementing survival analysis for predictive modeling.